Each M&M in this bowl weighs a slightly different amount. I want to identify a weight range where if I pick any M&M out of this bowl at random, I have a 95% chance of it falling within the range I identify. Today, we're talking about standard deviation and the normal distribution. Hi, I'm Jen. In the last video, I talked about calculating variance. For this bowl of M&Ms, our variance is 0.05. Once we know our variance, standard deviation is very easy to find because it's just the square root of the variance. Taking the square root of the variance on this bowl gives us a standard deviation of 0.22. When we have a normal distribution of data points, the standard deviation tells us a lot of information about our population. What's a normal distribution? When we graph a normal distribution, it looks like a mirror image from one half of the graph to the other. We can also see this with our basic central tendency data of mean, median, and mode. In a normal distribution, they'll all be the same value. In the case of these M&Ms, here's the distribution of those values. Our mean, median, and mode values, as you can see, are not the same for this population. You can see on the graph that our data is not quite symmetric and it's skewed slightly to the left. We have a longer tail out to the right at the high values. We call this positively skewed. If the curve went more to the right, we'd call it negatively skewed. What if this was a normal distribution though? When our data is normally distributed, we can subtract one standard deviation from the mean or average, and we can add one standard deviation to the mean or average, and 68% of our values will fall within one standard deviation plus or minus of the mean or average. If we take that out to 2 standard deviations, that will cover 95% of the values within our data. Add and subtract 3 standard deviations each direction, and you'll cover 99.7% of the population. That's great when we have a normal distribution, but we know the distribution of these M&Ms isn't quite normal. It's a little skewed. In the case of these M&Ms, it's better to use quantiles or percentiles to calculate those different ranges that cover the percentage of our data that we want to cover. At the beginning of the video, I mentioned that I wanted a 95% confidence level that the M&M that I picked out of this bowl falls within that range. So this means we have 5% that can fall outside of that range. So we'll take our 5% and split it in half and put half at the bottom and half at the top end of the range. So 2.5% each direction. Since I have 159 M&Ms within this bowl, or 159 data points, this means I'm going to eliminate 3 points from the bottom end and 3 points from the top end. This gives me a range of 1.40 grams to 2.32 grams, where 95% of the values can be found. We can write this as 1.40 is less than or equal to x is less than or equal to 2.32, where x represents any random selection of M&M from this bowl. Let's look at how to calculate standard deviation in Excel. We're starting out with the same data set we've been using throughout the series. I have all 159 data points on M&M weights here in the spreadsheet. I also have my measures of central tendency already calculated from the Intro to Stats video and my variance data from the last video where we talked about variance. To find standard deviation, we need to take the square root of our variance. We'll use the formula SQRT to do this. To use this formula, we'll type in the function and then reference our cell that has that variance value in it. We could have also done the same thing using the function stdev.p and referencing our total list of weights without having to do any additional calculations ourselves. We would use stdev.p because we're looking for the standard deviation using data points for all members of our population, in this case the bag of M&Ms. If this were a representative sample of the entire population of peanut butter M&Ms, we'd use the formula stdev.s to indicate our data is only a sample. This would give us a slightly higher standard deviation representing the fact that our sample may be slightly different than the actual population. So standard deviation is estimated to be higher in those cases. If you're using an older version of Excel or a different spreadsheet software, you may encounter the formula STDEV without the ability to specify whether it's for the population or a sample. In this case, it's the same thing as the version with .s that's referencing a sample. So it will give you a slightly higher standard deviation than if you were dealing with the entire population. If you're learning analytical skills because you're considering pursuing a career in data analytics or an area related to analytics, check out my book, How to Become a Data Analyst. I've linked it in the description below. It goes over the skills that you need to build, both the probability skills that we've been talking about, as well as other skills, such as programming skills, communication skills, presentation skills that you need, and gives you the resources to build them for free or inexpensively. Thank you so much for watching.